Okay, so let's take a look at this particular question. So Charles said that, are we looking at the same thing? That's right. We are at the worksheet. Can you look at the worksheet right now? Yeah, we are all looking at the worksheet. Okay, so Charles noticed that more force was required to move the wooden block across ramp A than ramp B. Gave a reason for his observation. Now, why does he need more force across A than B? Let's start from Eunice. Why do you think that is so?
There's no difference.
Yeah, you can't see the difference, but they're telling you that there is more force required to move from across A than B. What do you think is one possible reason for that? Eunice? Something to do with what?
Oh wait, the
surface,
yeah,
right?
Yeah.
What's so special about the surface for
rough.
B? Yeah. Right, so now let me write down the answer here. Right, so the surface, whoa, wait, give me marker. The surface of B, the surface of A is more rough than B, and hence there is more friction.
More rough. Is that a word?
Is it rougher? More rough.
Yeah.
Is it rougher? Is there such a word as
Yeah.
rougher? Rougher. And hence there is more friction, which requires more force. To overcome. Oops. Okay, right? So it's just 1 mark for this particular question, but that's the reason. So even though it's not seen, you cannot see it. Like one is rough, the other is smooth, but they tell you the observation, right? So you just write down the observation over here. Right, next. Right, so Charles repeated his experiment through using ramp A as shown below, and he measured the force needed to pull the wooden block using different angle x. So the graph shows his result. So how the pulling force changes as angle x changes. Now what does it mean? Angle x means now as angle x changes, what happens to the slope, the steepness? Is it steeper or gentler? If angle x increases, this thing becomes steeper. Now if it becomes steeper, do you think it's easier to pull or more difficult?
Easier.
Harder,
I thought you meant push down.
No, pull. Right? So this thing, it becomes steeper. Okay, angle x increases, it becomes steeper. So how the pulling force changes with angle x? So we say that as angle x increases, right, as angle x increases, the pulling force also increases. Right, so you do not have to explain why, because here they're just asking you to state, right? State how it changes with angle x. So basically one increase, the other also increase. And you know the reason why, okay? Because it's now steeper, so it's more difficult to pull it up. Right, next we have swing. Su Ying hung object A on a spring as shown below. She placed an electromagnet below and recorded the length. So which object is definitely a magnet? So we have two objects, right? Three objects, A, B, C. Which object is definitely a magnet? Okay, now the answer is A. Why? But why? Answer is A. Why? Now we need to use magnets. So, can I have the
That?
rectangular block? Thank you. Okay, now why is it 8? Why is it 8? Now, this paperclip, is it a magnet? This one,
No.
no, right?
You can magnetize it though.
Yeah, you can magnetize it, but it can attract. Okay, so it's a magnetic material. This is a magnetic material. It can attract. So, but can it repel?
No.
Can I repel this thing? Like I do anything? Oh, sorry. Can it repel? Sorry,
Yeah, can.
Cannot,
Push it away.
cannot. I have to push it away. But this magnet cannot push this thing away. So, but if I have another magnet like this, okay?
Small.
It's repelling, huh?
You can feel the repulsion.
Yeah, I can feel the repulsion, and if I let go,
Boom.
it sort of
Magnetic
flies.
cannon.
Yeah, it sort of oops.
Maybe they invent a magnetic cannon that
Trying
shoots
to
for close range combat.
repel. Okay? What does this mean? The only way to determine that this is a magnet is that it must repel.
Wrong side.
No, it's
It's correct, but it's
it turns again, so like that. Okay, it must repel. Okay.
Wrong side.
It must repel. See?
Yay.
It's repelling. Okay, so you know what I mean? The only way to determine another object is a magnet is it must repel. So if you look at this option, now there are several numbers here. We have 8, 10, 14. Which one shows repel? Which one shows repulsion? A. Why?
The string actually got shorter.
Yes, very good. Okay, this spring here became shorter because this electromagnet actually repelled the object. Repel. Okay, so you need to understand the options, right? So the answer is A. Object A. Why? Why is object A definitely magnet? Because it repelled the electromagnet repelled object A as seen in the reduction of the length of the spring. And only magnets can repel another magnet. Alright? That's it. Okay, only magnets can repel another magnet. Right, so it's repulsion. Repulsion will confirm that it is a magnet. Attraction cannot confirm that it is a magnet. Right, this is under push and pull forces. Right, so only magnets can repel another magnet. So you can conclude with 100% guarantee that object A is a magnet.
It could be a magnetized nail or something.
But it won't be
Diamond block.
not so powerful, right? Okay, what can you conclude about the property of material used to make object C? C. Object C, the paperclip. Okay? The paperclip is a magnetic material. Right? So we will say that object C is a magnetic material. So these are 2 marks questions, which means you have to give a reason for your answer. So how can we tell that it's a magnetic material? It was attracted to the electromagnet as seen in the increase in length of the spring. Right? So we are referencing to the data. The data says that when the spring increase in length, it means that there is attraction. Okay, and since there is attraction, it is definitely a magnetic material. That's what we're saying here. Right, next. Okay, so Hafiz want to find out if the area of a plastic sheet affected the time a toy took to fall vertically. So the diagram shows the setup which was dropped from a certain height, and we have the recordings as shown. So what's the question? What could Hafiz conclude? Okay, so as you can see the diagram and the data says that as the plastic sheet area increases, what happens to the time taken? Plastic sheet is this one, this plastic sheet. It increases the area, and then the time taken increases. That means it's coming down slower. Can you see that? Coming down slower.
Slowly?
Slowly. So what can you conclude? What's the conclusion? So based on the information, what can you conclude? The bigger the surface area, the longer it takes, right, for the parachute to reach the ground, right? So we can conclude that the bigger the surface area of the plastic sheet takes to reach the ground. Okay, so here they have not asked you for an explanation, so you don't have to go into the full explanation, right? But do you understand why? Why is it that the bigger the parachute, the longer it takes to reach the ground?
Xavier?
No? No, the bigger the parachute, the longer it takes to reach the ground. Like,
Oh, wait, because there's more like,
small parachute,
okay, never mind. Got less surface
big
area.
parachute, same human being. This one takes a long time to reach it quite fast. If no parachute, how?
Nice.
Even faster. Pew!
Less
This
air
one,
resistance.
very good. Okay, the key word is air resistance. So which one has less air resistance?
A.
Yeah, the least air resistance, the most air resistance,
Least.
right? So where is the direction of the air resistance? Is it down or up?
Down.
No, up.
A up, yeah.
Up. So here we can see that it's like there are like many arrows, okay, pushing it up. Here we only have two. This one zero, nothing. We got one skull. Okay. Okay, so air resistance. It's a lot of air resistance. That's why it takes a long time to reach.
Actually, the person that also has a bit of air resistance.
A bit.
Below him.
Yeah, so
The
it's,
hair.
but it's like little bit here and there.
The hair.
Yeah, the hair. But
So it's good to be a girl.
but your hair is not going to help you.
It's gonna kill you. No, but he has a lower chance, like slower.
Like you
It's
and
lower
then
than the
strangle
guy.
you.
Like let's say we put the guy here, then the girl here. The girl will drop slower than the guy.
Yeah, 0.0001
No,
second.
Oh, still die, right?
Yeah, but she's right. No, it's 0.00001 second slower.
Unless the girl's here.
Yeah, very good. Okay, unless the girl is here, because the girl is a lot. I'll see.
Diabetes.
No,
I will just eat it.
okay, so the hair does it? Yes, it increases the air resistance, right? Bigger surface area increase air resistance. Okay.
But unless the girl is heavier.
Heavier. Okay, so next you see that's what the B is asking about. How Hafiz to find out if the mass of the toy soldier will affect the time taken? So what can he do? Now this is just to describe an experiment. He can. I'm not gonna write it out. Just talk about it. Basically, what he can do is he can use different mass of toy soldier. So one could be 50 grams, another 100 grams. But this must be the same. What must be the same?
The shoot length.
Yeah, the area of the shoot has to be the same. Okay, the area of the shoot has to be the same. But use different mass and then he take timing. Okay, to check how it will happen. Right, next one. So I'm going pretty fast now because it's 4:15. We have some more questions to go through. No, it's not break time. No more break already. We're going to zoom all the way, right? So because we have so quite a bit to cover, so we're going to have to go quickly. Okay, so next one. Now if you look at the next setup, right, you can refer to your notes or you can look at the TV, the screen over here. Right, so in this setup, we actually have a device where there's a bowl over here. You put a bowl here and then the animal will come because it's hungry. Right, so it's like you put the bowl of food here, animal comes over here, step on this thing, and supposedly this device will cause the camera to automatically take picture. So the question is, how? How does it work? How does this thing work? Right. Okay, please do not spend time copying, right? As I mentioned, we have all this in digital format, so I can give you the solution. So let me explain. Now, how it works is this. When the animal lands here, at this hut, what will happen to this spring?
Boom.
You go down. Right? Boom, goes down. I don't know if there's a boom sound, but you go down, right? And then what's going to happen
Break.
next one?
It will be attracted.
Attracted or closed circuit. You say closed circuit, right? Electricity closed circuit. So when this thing closed circuit, it will take picture because it's closed circuit, and then you will see the animal. Okay, so we explain.
But what does it take a picture of?
The animal.
Okay.
Because it could be like a bird that always flying, and then you cannot change after the bird. So what do? You put the food there. The bird will come. But it doesn't know that when it comes here, it's somebody take a snapshot of.
What's so bad about taking a picture of a bird?
No, it's not bad.
Like that bird.
Okay, next. We placed a setup in the garden. He noticed that small animals have been feeding on the food, but no photographs were taken. Why?
Oh, because Gemma. Oh, not enough memory in the photograph. Why?
That is a good answer. But that's not the answer that they're looking for.
Who bought the back camera?
Huh?
Who bought the back camera?
No, wait, I think I know, but I don't know. Can you
Because the bird is not the
Okay,
not
so
the dinosaur.
in
Wait, I
the
know.
new scenario, they say got little animals. Now they're trying to catch big animals, but now instead of big animals, little
Is
animals
it they fly?
become.
The
Yeah.
mess is not ants.
Yeah, the ant come. Then how? Will the whole thing come down because an ant? So no. Right? So why?
The mess.
Yeah, it's, the mass is too little to cause the spring to go down. Okay, so that's it. That's the reason, right? It's too small. Next one. So one change that the photographer can make so that the camera will take photograph of smaller animals. What do you think
Oh,
he can?
the
Change.
spring can be lower.
Yes, very good. Okay, you can see the picture over here, right? Make it smaller, the distance. Make it smaller, right? And then after that, the animal will be able to.
The fox.
Huh? Yes, bigger screen also can. Okay.
How come it's a bigger screen?
Because it's weak. Weak. Do you say big or weak? Weak, right? Weaker. So it's not so stiff. It means it will compress easily. Okay, next one. I'm gonna get just now the two forfeiters, right? Come and explain. Don't need to do chicken dance, okay? But just explain. Okay, first one. Who wants to take this? Eunice or Jared? I mean, the answers are there. You can see the answer, but just need to talk about it. Okay. Eunice, do you know how to explain this? How can you tell that the strength is the same? How can you tell that the strength of the two magnets is the same? Oh, I should cover the answer actually.
Both of the attracted.
Eunice, Eunice. How can you tell that it's the same? Same number, very good. Okay, you can see the answer here. Both of them attracted the same number of paper clips, but you should add one more at the same distance. Alright? Same number of paper clips at the same distance. Okay? Same distance, same number of paper clips. Next. Okay.
Hey teacher, how come
Yeah.
like that? You see, here
What?
cannot repel.
Where?
Here.
Oh, because there's north south, north south.
Yeah, but there's no.
One north, one end north, one end south. Okay, next. So Alan switched off the power supply. The paper clips fell, but not for the steel. How come?
Still is actually it's still magnetized.
Yep. Right. So this person switched off power supply, switched off, both switched off. But how come this everything dropped? So this still like this? Okay, it's because the whole thing has been magnetized. So in the part B, why do they use iron for the recycling plant? Why don't they use steel? Recycling plant.
How's the
So imagine recycling plant.
Still
Recycle this thing, right? Alright, so they take this. What do they do in the recycling
release
plant?
it.
Why must release?
So you want to still sticking there.
You want this thing to melt, correct? You want to throw somewhere, you can boil this and melt. But imagine if you put here and then it cannot come down.
Then make the magnet fall down.
Useful or not like that?
No.
Then you
drop
throw
the
away
magnet.
everything. Think someone.
No, drop the magnet.
Okay, so this is what they are asking about, right? How come in the recycling plant they use iron? They don't want to use steel because you need the paper clip to drop. You know, you cannot keep holding the paper clip like that in the recycling plant. Okay, so that's why we say that in the recycling plant, they need the core to release the materials. Okay, they need the core to release the material so that it can be recycled, right? Okay, don't worry about copying, right? We will try to give you a copy of these answers. Okay, next one, next part. Here. So how did the distance from the sensor from the electromagnet affect the reading of the sensor? How did the distance? So there are two distances here. One is 25 mm and then the other one is the 50 mm. The distance from the electromagnet. So how do you affect? So the further the distance, the weaker the reading. Right, the further the distance, as you can see here, 50 mm is further than 25 mm. Right, so the 50 mm registered a smaller reading, smaller than the 25 mm. Right, next. Okay, next. What can Alan do to increase the strength? You want to increase the strength, you increase the number of coils. Okay? Electricity, yeah? Use more electricity. Okay, next one. Let's have Jared. Can you try this? 14?
Oh, okay.
I'm gonna try this question.
I'm not standing.
Huh?
I'm not standing for a big race. I'm sitting down too long.
It's okay, up to you, right? So why someone could slip and fall? Wait, listen. Later your turn.
It's because the water will reduce frictional force.
Correct.
So when someone stands on the water, he will not remain standing there, but will just slip and fall.
So you're just trying to say that the water reduces friction,
Yeah.
right? Correct. Okay.
Mm.
Answer here. When the floor is wet, there is less friction between the sole of the shoes and the floor as the water is lubricant. No. I'll pass all this to you, right? So therefore, someone could slip and fall. Right? So what's the key thing here? The key thing is this.
Less friction.
Less, not legs, less friction. But you see, another mistake that most people do is they just say less friction, but between what? The universe. Is it suddenly the whole earth got less friction? No, it's between the shoes and the floor.
Wait, do we have friction by holding the pen?
Yes, if there's friction, it will drop down. Okay?
But there's friction like if I do this.
Yeah, there's friction.
Harsh.
Don't keep showing friction, okay? Okay, next.
Steep.
Okay, next. Next, Tom experimented with 3 different types of antimats. Okay, what's the question? Right, so based on Tom's result, which anti-stigma is best at preventing people from sleeping? Sleeping. Right, is the one with the steepest. It is 65 degrees. So this is the steepest. Steepest means what? They put this up very steep, but the thing didn't come down. That means it's very rough. The surface is very rough, right? So there's a lot of friction. Right, next. So just put a tick there. The variable that Tom should keep constant in his experiment, the size as well as the starting position. Right? The size and the starting position. Okay, next one. Now next one I want you to try, because this is one question that once again it looks easy, but then there are some errors. Okay, everyone try. Everyone try this. First of all, do you know what it's talking about? Okay, let me try. Okay, let me show you.
Oh, yeah, I know already. But what's the property? Shit. Smooth. How many iPads do you have?
No, this mini.
Yeah, it's still an iPad.
It's mini. Okay, see this one. How come they don't make very smooth surface? Why do they have all this
Patterns.
pattern? And then
Reduce
it's like
friction.
up down, up down, up down. Reduce friction?
No, decoration.
No, not just decoration, right? It's for more friction. Easy to hold.
Really?
Easier to hold.
You mean use glass and what can wasted?
Yeah, can you imagine it's made of glass? No. Can you imagine it's made of glass, then it's very smooth. Okay, too smooth.
Can I try like iPhone X?
Yeah, you see, you can hold
iPhone.
hold the thing. I think it's charged already.
The whole thing is so textured.
Yeah, it's textured, right? So you get to feel the.
And this side is smooth.
Yeah,
So
from
it's
the-
better than everything without.
yeah. See? So it's easier to hold, right?
Harder.
Yeah.
Something.
So you see, you don't have.
So protective.
Yeah. Right? So you can hold the thing. So why? Same thing over here. Why does the handle have all these protrusions? Why? Why put the protrusions over there? Why? How about Gareth? Do you have an answer for us?
There's
Oh, sorry. The first one is about the property. Sorry. What's the property?
a solid material has definite shape.
It's a what? The hard
A solid material has definite shape.
definition. No, it's not about definite shape.
Solid material cannot be scratched by
Um,
material.
No. Looking for the keyword. That's not the keyword. Anybody else? There's one particular keyword that we're looking for part A. One word.
Friction?
No.
Reduce? Smooth.
No.
Reduce?
No. No, read again.
Okay.
Read.
Energy.
Rubber does not scratch glass because
Oh.
glass is
Smooth.
something
Harder.
harder. The glass is harder than the rubber, right? Harder. The property here is hardness. Hardness. Is it harder? Okay. So when something is harder than another thing, it will not be scratched. That's it.
Okay.
Right? Because it's harder than the rubber strip. So next part, there are many raised dots on the rubber cover. So how does the raised dots help the worker to have a better grip? That's not really explained. Actually, we already explained that, right? So he will have better grip. Okay, as you can see here, the raised dots increase the surface area, just like this thing. There's raised part, increase the surface area. So increase the friction. So increase surface area, increase friction, and therefore he can grip easier. Okay? Hey, we already know you very lovely, don't have to keep boiling the water over here. Okay?
But how does this happen?
Oh, okay, yeah, I need to explain this, right? Now, why is it that when you put your hand here, the water will fill up?
Gain heat, expands,
What
No,
expands? Is it
air.
the water or the air?
air.
Correct.
Air pushes it up.
The air inside here, the air expands. Then you push the water, force the water to go up. So if I put my hand here,
Science.
the air here expands, force the water to go down. So you want to see who is hotter? What do? One person hold bottom, one person hold top. See where the water goes?
Really? Can we try that?
Yeah, so the hotter person will cause the water to go.
Can we try?
Yeah, of course we can try, but let's try to finish a bit more first lah. Okay, okay, then later we play this. So one person hold.
Actually, number game after that.
See? So you
Can we
keep
do
going
a
down.
new question?
You hold the bottom, you go up.
No.
Okay, wait. No, let's keep going. Okay, next. No, next one. Come on. Next one, helicopter.
How come that question very familiar?
Is it?
Yeah, that question is exactly the same as the one in my school.
Yeah, so because we get this from a lot of schools prelim papers.
This is
Prelim.
what I see on paper.
Yeah, so they put it into your CA1.
How much
Right?
do y'all get for CA?
I got 76.5.
That's very good, right?
How much you get? Fail.
No, yeah, okay.
On express one, I think you fail. B.
Okay, wait. Don't care, So we
You grade.
never mind. Let's take a look at this question. Why did Daniel carry out the experiment 3 times? Why must do 3
Oh, wait, I know.
times? Yeah.
Conduct, what's that called? Wait, I got do this in school before.
Yeah, why?
To ensure that the result is, what's that word called?
Someone said awesome.
Huh? Awesome.
Yeah, reliable. Yeah.
Reliable or accurate, okay? Fair test, reduce human error, right? Make sure the result is accurate. So why the distance traveled by each of the helicopters was different for each try? How come, when you see the mass is the same, but then the result looks very weird. The result is all over the place. Why? What happened to him?
Probably the wind blew it down.
Yeah, could be wind, could have. So for him to do this, he needs to stretch the rubber band. Right, he needs to stretch the rubber band. So in the experiment, they did not describe how did he stretch. Is it using the same length, same strength, or he anyhow stretch? So likelihood is that he did not take into account the amount of strength that he needs to put in, okay, to stretching the rubber band. Right, so we say that it's possible that Daniel stretched the rubber band to different lengths. So the different lengths, of course, cause the helicopter to be launched to different distances.
What about the wind?
Wind possible. Yes, wind also possible.
Can you go to the toilet?
Yes, please go ahead. Right, so it's possible. Next one. So very easy questions here.
Martin Luther.
Okay. Okay, so the next part, Luther, right? Apply an increasing amount of force on material W. No, you can look at your question. So he recorded the results and showed. What property is being tested here? You have different thickness, and then you put things on top to see whether it will break.
Oh yeah, strength.
Yeah, very good. Strength. They're testing the strength the strength of this object. So one of the variables is not fair. Which one is it? How come you want to test the strength? There's something wrong here. You shouldn't do this. When you're testing the strength of material, you did something wrong.
Oh yeah, the material should be the same. The thickness of the material.
Ah, correct. Ah, you're getting it already, right? The thickness should be the same. Okay?
Always the same.
The thickness has to be the same. The thickness is not the same. Can you say that one material is stronger than the other? When you use a very thick one, then the one is very thin, and then you say that, oh, because I put here, this thing never break, but the other one breaks. Alright? Okay, next. So what should he change? Right? You give them the same thickness. Right? Next one. Why the block slide downwards after Jay Woo released it?
I think it's the feelings.
Yeah, these are metal foulings.
Why doesn't it come out?
Because it's stuck. Magnetic attraction.
Whoa, this is cool. Wait, look at this.
What?
Wait.
What?
You see that?
Yeah, flying foulings, right?
That's so cool.
Flying powder. Flying powder.
They fly. Just I saw.
Okay, you can go and try it out yourself, okay? Okay, but can you try the next few questions now? Come.
You should just use the feelings.
Hey. Come on. Olivia.
Wait, what question?
18.
Friction.
What?
Are you?
Question 18. Very interesting, right, the magnet? Yeah, when I bought them, I was also like, doing the, how many sweet is that? Huh? 4. Okay lah. Still okay lah.
Oh!
Magnetic material.
I should almost. I did it.
Oh.
Can just go to
I did it
people.
again.
You can just go to people. I want to take that people.
Yeah, that's why I put magnets in my pencil case.
What's that? Oh.
What are inside?
Iron, yeah,
Feelings.
metal or
I
iron.
feel like you raise it.
Why doesn't it stick?
No, it's not strong enough. No. But that shows you the magnetic field. You know what's a magnetic field? Have you seen the magnetic field? It goes like this.
Oh look. Look like you're making a pattern. Wow. This part can go to this side. Wait. Is it way to this side? This part can go to this side. This part can go to this side. Yes.
Finish? 18?
Still find this more fun.
Okay, wait, don't do first.
Wait, one last time.
Later we challenge. No, don't.
Wait. Oh,
Yeah, we change the
you
temperature.
How many boyfriends you have? 0. Go get one.
You the first one.
Okay, come. Later then we try, okay? Come,
If I get one, it will explode.
Come. Go here. Okay, now let's look at the question. 18. So why the block slide downwards after J.U. released it?
The friction was higher when the block reached.
Why did it slide down?
Gravitational force, I think.
There's a lot of questions.
Gravitational force. Very good. Okay. Yeah, the answer is actually here. See, after
Expect it to
J.U.
be like
Gravitational pulling gravitational force pull the thing down. That's the fifth one.
Okay.
You know, pull the thing down. So the explanation is this: after J.U. released the block, the weight of the block overcame the frictional force, and hence it slide down. Right? So it's about the weight, gravitational force overcome the frictional force.
that doesn't need a track.
One more time. Wait, do y'all get the concept?
Yeah.
What's the concept? How come it slide down?
Because gravitational force turns into
No!
The gravitational force overcame the frictional force.
Yeah. You see,
Yeah,
why this thing don't come down in the first place? Because there's friction, right? So it doesn't come down. But if the pull is stronger than the push, it will come down.
pull is stronger than the push.
All the time, look at this. Look at this. I turn. How come you don't call down?
Because it's attracting the
No. Don't care about the magnetic thing, right? How come it doesn't go down?
It's not steep enough.
Yeah, it's not steep enough. So is there friction?
Yes.
There's friction, right? Friction prevents it going down. But if I make it steeper,
It can slide down. But they're too strong. Can you do this? Mine can. Mine can slide.
hey, try that. Right, let's see when you alamak.
You
Experiment
just slide,
fail.
Just like
Okay, so when I see it's slide down, right? Slide down. Why? Because the gravitational pull, gravity pulling down, is stronger than the friction between here and here. So it slides down. Understand?
You like the sound?
Right, so that is the concept. So that's the concept, okay? Next one, you go. Okay, so Jae-woo, the K-pop boy.
K-pop boy.
Yeah. He concluded that the two blocks stopped moving because there were no forces acting on the blocks.
There's a truck outside.
Okay, why he cannot make such a conclusion? Now, is it true that if something is stopped, like here, this thing stopped, right? Is it true there's no forces acting on it?
There is.
What forces?
It's being pushed on me.
Yeah, there's actually gravity is still, yeah, there's gravity pulling it down.
How do you put this in?
There's also frictional force. So there are two forces still acting on it, right? One is gravity. So that's why I say here, gravitational force. And then there's also frictional force is present. So he cannot conclude that there are no forces. Next one. Okay, can you try the next one? Yourself. Cornelia. 19.
好吃。Sorry.
消吃。
小吃。我看今天。小吃。
Okay, you need too many.
Experiment using this test.
Overdose.
How does it taste? It's nice.
Overdose.
It's sour. Yeah.
Also,
Sour.
Why don't you try one?
Yeah.
nothing. I like sour. I like
It's mostly sweet bar. Why can it be attracted like that?
Because magnetic field is bigger than the magnet.
Huh? Really?
Yep. This is what it's
But
supposed to
look,
do.
it's bigger.
You see, this is the magnet, right? But the magnetic field is like this. You cannot
you
see
can
it.
see it. You can see if you place it over here.
Yeah, correct. There. No, you just put it there. See it? You can see it. Magnetic field.
No, you place it down. Just place it down.
Yeah.
No, you place it down. Really, you can.
Magnetic field.
No, you can see if you lay it lie down.
Can you see me?
Yeah.
You can see a shape. You can see a shape.
Lie down, lie down.
No other. Lie down. Push it. This. This.
Right down.
Yeah, lie down. Wrong way. This square or what? Yeah, square. Okay. See, you can see a shape.
Oh.
Put in the middle, right? Put in the middle. There, can you see? Going how big is the magnetic field?
Yeah, I discovered it.
Yep, that's the purpose of this
Discovery.
heat.
So it's cool.
See how big it
That
is?
very, very cute. Wow, that is very, very cool. Now it's small.
Yeah.
This is very cool.
Oh,
Yeah.
I have to take this.
yeah, let me try. Sorry, man. Is there only one paper clip?
Yeah, I only have one here.
Oh, okay.
Yeah, do.
Check, please.
I want to see the colors of this.
Does string of magnetism affect the tangent fluid to attract something?
The what? Sorry, the?
Attract something.
Yes.
Very heavy and then very
Yeah, yeah.
strong and different strengths, then the thing, the time is affected.
Yes. What are you doing? Rubbing your leg.
Yeah, leg feels warmer than my hands. My hands are usually colder.
Can we play now?
It really works.
Yeah, okay, let me do 2 more questions, right? And y'all try to see who is hotter.
Me lah.
okay, put down.
This is a hole there leaking.
Yeah, there's one tiny hole there.
Why is it tiny hole?
What if there are many magnets on this?
So there are
Just
many.
go, just go
magnetic-
everywhere.
There will be many magnetic fields affecting the.
There's a wall.
It's like here, you see? Look at this.
Oh no, it's good now. Oh. I need back up.
Oh. You keep rubbing your leg. Is it up and down?
No, it won't happen. I'm going to the end.
All your legs are all sticking out nobody there the whole thing.
I'm quitting. Ow! Still open the top.
You do know he has another.
No need to hold too hard, right? Just use one hand.
And I'm going to rub on. Rub on everything. Everything. Rub everything.
Oh, we can move.
Oh, shit, lost.
Yeah.
How do you get it back in?
Just wait lah, leave it there. It will go
Good
back.
as a hole?
Yeah, it will go back. Right? Due to the temperature difference, it will go back.
Don't
Okay.
make your hotness when you go up again.
That sounds right.
Okay, come on, let's take a look. Okay, we try 2 more questions, right? Let's do
Let's
2 more.
It's going up again.
Yeah, let's go. Let's do 2 more. So first one, part A. So based on Xiaoju's results, did the volume of the block affect the amount of force acting on the spring? Did the volume? You see, they changed the volume. Right. Look at this part. Volume was changed. Did it affect the result?
Maybe?
No. They changed the volume from 80 to 100, but the result is the same. Volume change, result same, right? So what does this mean? Does the volume affect how much the spring is being pulled? No. So what affects how much the spring is being pulled? What affects the length? Yes. Yeah, right. The mass.
Mass.
Mathematics.
No.
Mass. Right. Mass. Not mass.
It doesn't go down.
Let me see. He was
Keep away from hot people.
Yeah.